Hey everybody, welcome to our first guided problem. These guided problems are meant to help you work through the homework sets, and so they're not meant to be crazy hard, but they are just an opportunity for me to work out a problem for you and for you to do it. They're also not worth a very huge part of your grade, I think 10% total. So if they become cumbersome, some people choose to skip some of them as they don't have the time. It's just a chance for me to work out a problem so that you can follow along with it and do the problem. And it's meant to be an easy A. If you just follow along and work out the problem in your homework set or in your guided problem, then you'll get an A on it because you'll be just kind of doing what I'm doing. And then that will prepare you to be able to do the regular homework problems. Anyway, so this first chapter is going to be a little different because instead of it being math type problems, these are more like multiple choice. So I'm just going to go through and try to explain them because these concepts are a little confusing at the beginning of the course here. So these are asking us if our data sets are qualitative or quantitative, and then it's going to ask us to identify the level of measurement. So first, we'll just break down what qualitative and quantitative means. So qualitative data is data that uses descriptive terms rather than numerical values for measurement. So, and then quantitative data is data that uses numerical values that we use numbers to measure. So this first one, it asks us, we're going to find the average temperature of water samples taken from a lake. And so that's definitely going to be quantitative, right? Because we record temperatures with numerical values. And then, so that narrows our choices to B and D. And it says quantitative because numerical values found either by measuring or counting are used to describe the data. That's our correct answer. This one tricks you. It says quantitative, but then it says because descriptive terms are used, so it uses the definition of qualitative data. And then it's going to ask us the level of measurement. And so we have 4 different levels of measurement that we use. And some are used only for quantitative data, and some are used only for qualitative data. So that can help us. So we have what's called nominal. That it means by the nominal, the prefix of that nom means name. So nominal data is data that really can't be ranked in any way, and it's just listed by its names. Think of if we just had a list of names of people in a class, that would be nominal data. So, and then ordinal data is names, but they're names that can be ranked. A good example of that might be what if people are freshmen, sophomores, juniors, or seniors. Those are just names, but they're ranked, meaning freshmen are students who've only been in school 1 year, sophomore 2, etc. So those are our 2 measurement levels for qualitative data. And then for quantitative data, we have ratio and interval. Ratio means there's a meaningful difference between the numerical values that we've assigned. And that the data do not have a true 0 point, or I'm sorry, do have a true 0 point, that's ratio, 0 point. So an example of that might be weight. If we're weighing different objects, certainly there's a meaningful difference in weight that can be expressed numerically. And if something has no weight, then it would have a weight of 0 pounds or 0 kilos or whatever unit we're using. Interval data can also be meaningfully measured, but it does not have a true 0 point. So something like temperature, if we say that the temperature is 0, it doesn't mean the absence of temperature. Instead, it means that if we're using Celsius, that we're at the freezing point of water, and if we're using Fahrenheit, that we're some point 32 degrees below the freezing point of water. But it doesn't really mean that there's no temperature there at all. So in this case, we identified this temperature as quantitative data, and it's going to be interval because we have meaningful differences but do not have a true 0 point. All right, so number 2 is a similar question. It wants us to identify if this is quantitative or qualitative, and we're measuring eye color. So eye color is not quantitative, not numerical, so it's qualitative because descriptive terms are used to measure or classify the data. And the second part is going to ask us what level of measurement. And here it is, so color, blue, green, hazel. So that's going to be nominal because these categories can't really be ranked in any way, right? I mean, I guess you could have a preference that blue is better than green or something like that, but it doesn't really mean anything. So we're going to call that nominal data. All right, number 3 is going to be another similar one. Let's see. So type of data and the level of measurement for heights of students in a statistics class. So height, how tall someone is definitely quantitative. We'll use numerical values. And then its level of measurement. The question is, can we have a height of 0? Meaning the absence of height, and that in fact could be the case, right? Something that does not have any height would have 0 height. So we're going to say that this is ratio data because it does have a true 0 point. All right, another one, type of data and the level of measurement, names of students listed in order of grade point average. Okay. So if the data we're measuring is, well, I don't like that one. If it's their names, we're going to say that that is qualitative because it makes no sense to perform mathematical operations on the data. I don't know if I like that, but that's what it says. And then what's the level of measurement? So this one, again, what's tricky about this one is it says it's the names of students listed in order of grade point average. And so to me, that means it's ordinal because we can put them in order, but I'm going to see if it likes this answer. It does. Okay. Sometimes these are a little tricky. That's why I'm kind of walking through them. All right. The table to the right shows the price of a novel at a certain bookstore during 2009. Identify the data as either time series or cross-sectional. Okay. So if we have a single piece of data and then we're following how it changes over time, that's called time series data. So our answer is the data are time series because the data are measured over time. All right, here we have a table that shows median weekly earnings. And so hopefully my picture isn't blocking this. I hadn't thought about that. That's one of the downsides to this program. Maybe if I make this a little smaller, then my picture won't be blocking it if it's there. All right. So median weekly earnings of full-time workers by height over a 5-year period. Tall people make more money or what? So here we have time series data where we would have a single piece of data measured over time. And we have, I just drew a blank of what it's called. So let's just read the question. What are the time series data? So the time series data are these columns that describe each individual piece of data measured over time. So the time series data are the 2 columns because they show values taken from a single subject across 5 years. All right, same thing. Here's our table. It's going to ask us what our time series are. In this case, the time series, again, is going to be our columns, right? Because it has a single subject measured across multiple years. So the 2 columns because they show values taken from a number of subjects. No, they're time series because they show values taken from a single group across 5 years. I'm sorry, 2 columns because they show values taken from a single group across 5 years. All right. And now they're going to ask us about descriptive or inferential statistics. So based on a random sample, it's concluded that the average cost of a hotel room in city A has decreased over the past year. Okay, so In inferential statistics, what we're doing is we're making inferences about a whole population from a sample. And then in descriptive statistics, we're just summarizing information that we've seen. So in this case, we take a sample and then we make this conclusion about all hotels in the city. So we're going to say this is inferential because it uses sample to make a claim about a population. Let's see here. The average price of a random sample of 10 books is $5.25. So this is descriptive because it summarizes the information in a sample. It doesn't make any inferences about the population. Let's see, and then a sample of 750 viewers in country A showed that viewers watched more hours of TV a month on average than a sample of 750 viewers from country B. So again, we're not making an inference about the whole population with this statement. We're just saying it summarizes this information from these two samples. So that is descriptive statistics. And that's it. So I know that this first chapter can be a little confusing. There's a lot of terms you're not used to and a lot of concepts that you have to sort of just try to understand and work through. But it'll be worth your time as you go through it to really try and understand the difference between each of these concepts. If you have any questions, don't be afraid to email me or text me or give me a call. Thanks very much and have a great day.